What are my other entries?
You know what? I learned how to push.
Yeah. I have to I go.
Okay, now remember, this exam will be Thursday and Friday, this period, all right? The first 19 problems, which you're gonna actually do Friday, are just like these 19, but it's multiple choice. 20 to 30, we'll do Thursday, but then you have to write out, you have to write those out like normal. You show me some work.
Wait, can we do the harder one first?
Yes,
Oh, I'm excited.
so, set builder notation always starts like this, and that'll, all four of your choices will already be in set builder notation. You just gotta make sure that the inequality is correct. So what number has the solid dot on it? -3, so it's less than or equal to, because it's a solid dot, right? Then the X, then it's a circle on what number? 4, so it's just less than 4. Just pay attention to your inequality symbols, okay? And your numbers on your number line, make sure you're picking the right numbers.
Systematically.
Yeah.
Will always be less than.
Well, if it's going towards each other like that, if they're going away from each other, it might be the other way. But it's probably gonna be less than, yeah. All right, we're simplifying a radical for number 2. Since both of these numbers are under the radical sign, I can reduce that fraction like I normally would. What number goes in the top and bottom? 2. So divide both by 2. And you'll get 25 over 49, which are nice numbers when you have radicals. Yeah, they're perfect squares. So just take the square root of each one, and that's your answer. 5 over 7. Okay? So I would assume, not supposed to assume stuff, but I would assume it's going to be very similar, where it's going to be a fraction that you can reduce, and they'll end up being perfect squares, and you just find the top and the bottom on them.
So I kind of did it like that, but I got 5 radical 2 over 7 radical 2.
So the radical 2's cancel.
So the names is canceled.
Yes. Okay, number 3, just simplify the expression. This is stuff from earlier in the year, but it's similar to what we just started in chapter 6, right? Just combining like terms for our polynomials, our monomials and binomials and trinomials we started talking about last week. Okay, so what are the like terms? The S squareds, right? So 1s squared and a 5s squared is 6s squared.
No, 6s squared.
Oops. You get plus t. Okay.
No,
Just how it came up.
a little scribbled on the paper, I couldn't tell it.
Well, just look close.
I did put T though.
Number 4, we are multiplying 2 monomials, I guess we could call them. We didn't call them that back when we did this. But that's what we're doing. But first of all, Aunt Sally says to do what's in parentheses first. Can I do anything in either parenthesis to make it simpler? No. So the second thing Aunt Sally says to do is exponents, right? So that's what I do. I take -5 to the second and a to the second, which is 25a to the second. Positive, right? -5 times -5. And then the other one, it's got exponents inside and out. What's the rule when there's inside and out? Multiply, yeah. So that's a 10 and a 5. Now that I have this monomial times this monomial, I multiply the coefficients. 25 times 1 what do we do with the exponents?
The average.
We add them now. So this is a to the 12th and b to the 5th. Again, it'll be a multiple choice problem. So all you're gonna write is, A, B, C, or D for me. So pick the right one.
Wait a second. Oh, no. Go up for a second.
Why are you so slow, Joe?
I was trying to understand.
Grandma was slow because she's old. You're not old.
Alright,
You're young. You should be quick.
I was trying to learn.
You should have learned it the first time we did it, back in August, September. Oh, that's right. You were too busy golfing. Maybe that's why. You did a good job golfing too. Okay, there's two ways I showed you how to do these. Most of you probably just distributed, right? And that's nothing wrong with that. But I also showed you that you could take that -4 to the other side first. How would I take it to the other side? Divide it. Multiplication, Joe. But most of you probably just distributed, so that's how I'll do it. But we could have, if you wanted to, or if you want to on the exam, whatever's out front here, if you divide, you get smaller numbers then, right? That's the only difference, just a little bit smaller numbers. But -4 times 24 is a -96, and a -4 times 8 is a -32. Why? And then we're going to take the 96 over. So we're going to add that because it's a negative. The opposite is positive. Don't forget it's a -32. Why? And what's that? Positive 32? Divide by your -32. So y is -1. So just solving an equation. You guys are good at solving equations. Number 6 says solve and graph. There's only one variable, so the graph is a number line graph. Okay, when you get an x and a y, then it's, an xy graph, right? So number 6, it's a number line graph that you're going to see for your choices. We've got 5 times the quantity, -4 plus 2x, greater than or equal to 2 times the quantity, 5x plus 4. So distribute first, and I get -20 plus 10x, greater than or equal to 10x plus 8. So I got an x on each side, so I want to get them on the same side. So I usually take the x on the right and move it to the one on the left. So that's what I'll do. So I'm going to subtract 10x. Well, what happens on both sides? They cancel, right? On both sides. No more variable. So looking at this statement right here now, because the x's are gone on both sides, is that a true or a false statement? False. Therefore, we would say what? No solution. Okay? Now, your choices will be graphs, number lines. So what's a no solution number line graph look like? It's just a number line with nothing on it, right?
Oh, there you go.
Okay? So your choice would be the one that has a number line with nothing on it. No dots, no circles, no lines, you'll just see the numbers, okay? You want to put, so just understand. What if this was a true statement? What if it said positive 20 is greater than or equal to 8? That would be true, right? Then what do we say the answer is? It's a true statement when all the variables cancel out. All real numbers. Now, what's that number line graph look like? So would be a number line, right? So I make a number line here. You know, we got our numbers. Then you're gonna have it all covered up, right? Whoa. You know, it'll be like really thick over top of everything. That's all, that's showing everything, right? So if it's no solution, you'll just see the number line part, but no arrows, no dots or anything, okay? If it's all real numbers work, it'll be a solid line, you know, maybe thicker over top of the number line. So it's showing you that all real numbers work. So just realize that when it's a multiple choice type problem. Okay, slope intercept form. You might want to write this on your little card, but I think all of you know that one anyway. Another thing we did was point slope. If you want to use it, you can for this. I'll write that out for you. Some of you like doing it this way. Okay. And then it said parallel to a certain line. And then it said through a point. And it got, your point got kind of split up, but it was -2, -4 was the point. Okay? So, what do I use from this to help me? When this y equals -2x minus 9. Why are they giving me that? Right. You look at the slope. Parallel lines have the same slope. If it said perpendicular, they're opposite reciprocals, right? So since this said parallel, I got the M part of my answer. They're the same. Okay? I use the point to plug in for x and y to figure out the y-intercept, the b part. Or you can put it up here in point slope, use the point, put in for x1, y1, -2 for the m, and then get y by itself, so it's in slope-intercept form. I showed you both ways when we did these. So, and I told you, whichever way you're better at, or you like best, you can do. So that still goes. Okay? I like doing it this way, putting the slope, so it's parallel, the same number in for m. If it was perpendicular, I'd use +1/2, right? Opposite reciprocal. And then I plug in the point. -4 is the y value, and -2 is the x value. And then I solve for b. And it comes out to be -8, it's 1b. So the answer we're looking for is this, y equals -2x minus 8. So that's
What does B stand for again?
y-intercept, where the line will cross the y-axis.
What one is that again?
This, slope-intercept. Any other questions? Okay, number 8, you have to graph that inequality. That's got an x and a y in it, so we have to do an xy axis. And the line is going to be dashed. Everyone remember why? Because it's not equal to, right? If it had the equal to, it'd be a solid line that we're going to graph. Since it's not equal to, just greater than, we're just making a dashed line. So when you look at your choices, make sure the one you pick is the one with the dashed line, right? And you gotta shade one of the sides, right? This is one where you gotta draw your line and shade either side. What's this, number 9, right? No, number 8, sorry. Okay, so it's in slope-intercept form, so it's really easy to graph. Oops, not equals. Greater than, sorry. So I got my y-axis and my x. So there's going to be 4 different pictures, okay? So if I were you, I would just draw it and then go find the one that matches the one you draw. All right, so -2 is my y-intercept. So I put a dot there, and then the 3/4 tells me the slope. So from that dot, I rise 1, 2, 3, and I run 1, 2, 3, 4. Okay, so there's 2 dots I can connect. Remember, it's supposed to be a dashed line. So make sure when you're looking for the right choice, it's dashed. And then how do I figure out which side to shade? Yeah, usually greater is above, right? To make sure we plug in the 0.00, right? So I'm just going to make sure I get 0 is greater than -2. That's a true statement, right? And 0, is there to the left of the line, so you guys are right, it's above. So make sure you choose the one that's dashed, that goes through -2, has a positive 3/4 slope, and shaded above it. Questions? That's pretty easy to do, isn't it? Hopefully. Number 12, solve the inequality and graph it. Again, there's only one variable, so the graph's what type of graph? Number line graph, right? One variable, number line graph. 2 variables, x, y graph, right? All right, so what else is true about absolute value problems? Well, yeah, they gotta be, the absolute value of something's always positive, right? It's the distance from 0 on the number line, right? But there's 2 problems, right? The first problem is what it looks like, right? If you just drop the absolute value symbols. And remember, greater is an or problem. Less than is an and problem, right? Well, this is an or problem. What's the other problem? Alyssa? Good.
Less than.
Close. Negative. Yeah. What changes is the inequality symbol will change, and you change that number to a negative. That's the second problem. Okay? And then I just solve those 2 and graph it. Usually the or problems go which direction when you graph them? Anybody remember? Yes. Opposite directions, the ors. Most of the time. Not every time, but most of the time. The ands usually go towards each other. Okay? If you want to add that to your little notes for your, you can do that. Remember, if you multiply or divide by a negative, what do you got to do with your inequality symbol? Flip it. But we didn't divide by a negative, so we don't have to flip this time. But just keep that in mind. -16 minus 12 is a -28. Divide by +4, so I don't flip it. there's my two inequalities that comes out of this. And I graph it. -7 is down here on the left somewhere. 0's here. 1's about there. Right? Solid dots or open circles? Or one of each? Open circles. No equal to, right? So circle it both. For the 1, it says greater than, so it'd be going to the right. And for the -7, it says less than, so going to the left. So it did go opposite directions like we expected. Okay? So, again, it's multiple choice, so, check your numbers, make sure they're correct, and then make sure your graph matches. They might give you the two right numbers, but one of the graphs might go towards each other. So pick the right graph that goes with it too. And then 10, last one for today, was solve the system by substitution. When we do the substitution method, the first step is to get one of the variables by itself. Well, that step's already been done for you, hasn't it? They already got y by itself for you. But if that's not the case, remember I told you to get one of the variables that had no number in front, a coefficient of 1. That way you don't have to divide by anything and get any fractions. Okay? Now, seeing that it's multiple choice, they're going to give you an X answer and a Y answer, right? So even though I'm telling you use substitution, you can just look at A, plug those two numbers in, see if it works for both. If it works for both, you're done. Then go to B, plug it in. If it works for that one, then B is the answer. See what I'm saying? So for the multiple choice ones, I'm not looking really for the right procedure or not. I'm just looking for the right letter. You see what I'm saying? So if you forget how to do elimination or how to do substitution or how to use the matrices, it's still going to have the answer there. You can just plug it in and see if it works for both. It's got to work for both though, right? You understand what I'm saying? Okay. So anyway, that means substituting x plus 5 in place of the y in the other equation. Make sure you go into the other equation and use substitution. Oh, I was going to sneeze. All right, so I'm going to put where the y was, x plus 5. That's the substitution part. Okay, so combine like terms, 3x plus x is 4x plus 5. And then we get x by 7. Are we finished when I get x equals -2? No. That's half of it, right? Now, you could stop at this point. If there's only one choice that has -2 for the x, it's got to be the right choice, right? But to finish up, we're going to put -2 right there. And get 3. So -2, 3 is the correct choice. Okay, but like I said, if you just want to start plugging in for x and y and see if it works in both, that's another way to do it, right? Even though you didn't use substitution. Questions? We feel better about the first 10? Okay, tonight's homework is 11 to 20. You could get maybe half of it done already. In the next, we got about 13 minutes. Okay, we'll go over 11 to 20 tomorrow. And then you'll have the last 10, 21 to 30 for tomorrow night. We'll go over that Wednesday. And then you'll start your exam Thursday. All right, good job. Again, if you just pay really good attention in class this week, you should be ready for the exam come Thursday. You're not having to do too much outside of class. Yes, ma'am?
So I didn't allow actually for confusion, but how do I graph
That's, you graph this,
is it a
both of
line or is it?
yeah, it's like this one, where this one here.
Oh,
You shade.
yeah, I did that.
So you would do two of them on the same graph, and where the shaded part overlap.
And then
That's just putting it in the matrix. When we did that, I did,
oh, is it in algorithm?
yeah. Yeah, great.
Oh, wait. Oh.
Yeah.
I appreciate that. I forget how, where we set up,
Yeah, you use those four numbers for the A. Again, you had
yeah.
You can draw.
What do you do?
Plug it in, put those in your calculator, not the X's.
Oh,
You're welcome. In my opinion.